Hello, welcome back to lesson 8.3, using a t-test for the mean. We are now going to apply what we've learned about hypothesis testing. So we're going to learn how to state the 6 steps in a hypothesis test and how to test a means when the sigma is unknown. So we're not working at all where we know the standard deviation. We're assuming that we don't know the standard deviation of the sample or the population using the t-test. So here are the 6 steps stating the hypothesis. We've practiced these individually: the level of significance alpha, the test statistics or the p-value, the graph, the decision, and the conclusion. So when we have quantitative data, then we can calculate means. So quantitative data. We're going to do a t-test. So the t-test is a statistical test for the mean of a population, and it's used when the population is normally or approximately normally distributed and sigma is unknown. So that's why we have to use the t-distribution. Then our test statistic is the sample mean subtracting the population mean divided by the standard deviation divided by, so this is another divided by, the square root of n. And our degrees of freedom are n minus 1. So let's just draw, we're going to get some practice doing some intermediate steps. Let's say we have a hypothesis where the mean is equal to 10. The alternative is we think the mean is less than 10. And I gave you the p-value, the probability of the H0 being true. This is the probability of HA being true under this hypothesis that the mean equals 10. What type of test is this? It's a left-tailed, because it's a less than, and we're going to draw the picture. And the likelihood of this is being 0.0935. That's all we want to do here is just practice that. That's a good example too. So this time we have the H0 is the mean is 1, HA is the mean is greater than 1. So that picture is going to be over here. Assume the p-value is this. What type of test is this? It's a greater than, so it's a right-tailed. And then my p-value is here. Look at. Let's practice finding some critical values. So far, our typical rule of thumb has been either being 2 standard deviations below or above the mean, or being 5% or less likelihood. So now we are going to be using more particular critical values, and we're going to practice finding those. So a critical value for n equals 16, we need to know the degrees of freedom, which is n minus 1, so that's 15. And for a two-tailed test, because it's two-tailed, then we're looking at alpha divided by 2, which is 0.1. So we're looking at t of 0.1 and 15. We can go to the back of our course pack where the formulas are, and we can find this. So at the very back of our course pack, there are the t-tables, and that's on page, right now it's 223. It may change the next semester. That's on page 223. And we're looking at 0.01. So 0.01 and degrees of freedom of 15. We're looking at 0.01 and degrees of freedom of 15. So right there, 0.01, and then we're going to go over here to 15 and 0.01, so it's right here, 2.602. Next up is right-tailed. So all of the area, the alpha is in the right tail, and degrees of sample size is 27, so degrees of freedom is 26. So we're looking at 0.01 and 26. So 0.01 and 26. So still at 0.01 as before, and then we're going down to 26. All the way down here, 26, all the way over to 0.01 right here, 2.479. 2.479. Next up, we have a left-tailed. So the left-tailed is 0.005 and degrees of freedom is 23. So 23. And we have to remember that this is going to be a negative t because it's a left-tailed. So we can still use our t-table, but it's a negative. It's on the left-hand side. So 0.005 and 23. 0.005 is right here. We're going to go down to 23. And we are right here at 23. So 23 and 0.005 is right here. 2.807. A negative 2.807. And then n equals 8. So we've got a degree of freedom of 7. And alpha is 0.05. It's two-tailed, so we have to do 0.05 divided by 2 is 0.025. So we're looking at, and this is, our two-tailed up here is plus or minus, because whenever it's two-tailed, there's really two of them. So this is also plus or minus. 0.025 and 7. 0.025 and 7. 0.025 and 7. So 2.365. 2.36. Plus or minus 2.365. Fabulous. Okay. Now, our T is in example 4 here. It says use the t-table or Alice calculator to find the p-value, the probability for each of these test statistics. So it's a right-tailed. So we want to know the probability of t being bigger than 2.321 when n equals 15. So we have our critical t. So the probability of t being greater than 2.321. Let's go to Alex for that. Okay, so we're looking at the probability of t. Now we have to remember that the t is a greater than. So because we want a greater than, we are finding the t that's greater than that. So probability of t being greater than 2.321. And then our degrees of freedom is 15 minus 1. So our degrees of freedom is 14. We'll put in 14 and hit enter. And that likelihood is 0.0179. Next up is B says it's a two-tailed And the probability of 1.945 equals 28. So we're going to do greater than 1.945 because it's a positive t. And our degrees of freedom is only 27, 28 minus 1, so 27. And hit enter. And that comes out to be 0.0311. Now letter C says the probability of being left-tailed and T being smaller. So because the probability of T being bigger is the only thing that we have here in Desmos, we have to do 1 minus. So 1 minus the probability of being bigger than a negative 1.267. And then we have to enter our degrees of freedom here. And degrees of freedom is 7 in letter C. And that likelihood is 0.1228. And then letter D is another, it's a two-tailed, so we can, and because our T is positive, I'm going to look on the greater than side. So greater than 1.562. And then the degrees of freedom is 16. And so that goes out to be 0.0689. I'm going to show you my paper so that you can see. So we just find the p-values, the probability of these happening under these assumptions. Chance to rate those. Okay, so we're gonna kind of put it all together. I'm gonna do one for you, and then we will try one on our own. So example 5 says statistics students believe that the mean score on the first statistics test is 65. A statistics instructor thinks the mean score is higher than 65. He then samples the students and obtains these scores. So our hypothesis statement is a step 1. And so we assume that the mean is 65. It's always an equal to. And the HA, this time we think it's higher. So that tells us to greater than. Step 2 is always acknowledging our level of significance. If they don't give you 1, you're assuming it's 0.05. So we're using 5% or 0.05. And step 3 says our test statistics. So our test statistic is the sample mean subtracting what we think is true. So our sample mean was 67. We found that by putting our data into Desmos and coming up with the mean and standard deviation. And then our sample standard deviation was 3.1972 divided by the square root of 10 because there were 10 in our sample. So our t-score is a 1.978. And we are using, when we use Desmos, or I'm sorry, Alex, we can see that our p-value, our likelihood of being bigger than 1.978, there's a sample size of 10, so our degrees of freedom is 9. That probability is 0.0396. Okay. So, interpretation of the p-value. If the null hypothesis is true, then there is a 3.96% probability that the sample mean is 65 or more. So not very high. Definitely less than 5%. Step 4 asks us to draw a picture of our scenario. So the likelihood of being bigger than 65 is actually the probability of it being 67 or more, I should say. The mean is at 65. Sorry about that. This probability is 0.0396. 0.396. So step 5 is asking us to compare the p-value. So since alpha, so we always compare our p-value. So in this case, it's 0.0396 to alpha. Alpha is 0.05. And because it's less than, then we reject H0. So when you're using p-value, it's always if your p-value is less than your alpha. That's always the rule. And then step 6. In other words, you believe the average test score is more than 65. So our conclusion is at a level of 5% level of significance, the sample data shows sufficient evidence that the mean average test score is more than 65, just as the math instructor thinks. Example 6. Example 6 says, it is believed that a stock price for a particular company will grow at a rate of $5 per week. An investor believes the stock won't grow as quickly. The change in stock price is recorded for 10 weeks and are as follows. 4323172112. Perform a hypothesis test using 5% level of significance. State the null and alternative hypotheses, find the p-values, state your conclusion. Be sure to label all 6 steps. Okay, so our first step is the hypothesis statements. And they're proposing the mean is 5, but some people are skeptical and think it's less than 5. They told us to test using at the 5% level, so alpha equals 0.05. And then we have to find our test statistic. So that is our sample mean. So when we put our data into Desmos, we get a sample mean of of 2.6 and a sample standard deviation of 1.838. So our t-score is 2.6, subtracting the mean of 5 and dividing by 1.838 divided by the square root of 10. Our z-score is a negative 4.1, or t-score is a negative 4.13. So our negative 4.13. So we're going to find our p-value. So the p-value is the probability of being less than that because it's a less than, so we're drawing our picture to the left. The probability of a sample mean being less than, actually it's a z-score because we've already normalized it, t-score. So the probability of being outside of that. And we have how many in our sample size? Sample is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So degrees of freedom is 9. And so this p-value is 0.0013. It's very small. Okay. The other way we can look is we can just say, what is the critical value? So let's find a critical value. So there's a number of ways to look at this. The critical value is the t at 0.05 and degrees of freedom of 9. Using our t-table in the back of the course pack, we get a negative 1.833. This is our critical value, meaning anything to the left of there is in a danger zone. So we are definitely in the danger zone. We are definitely in the danger zone. Hmm. So that is step 4. We graphed it. Step 5 is comparing our p-value to our alpha, 0.05. Our p-value is very small. And because our p-value is less than alpha, we reject H0. And so, because we reject H0, then our step 6 says there is sufficient evidence to support the claim that the stock is growing. The stock is growing on average less than $5 per week. So not as much as we thought. Not quite as much as we thought. Okay. I would like you to do this one on your own, attempt this one on your own, and you will add these into Canvas assignment. And it will help you make sure that you are getting them correct. So you'll read through this and add your questions in, your answers into Canvas, and make sure that you're understanding how to assess these, because this is going to be part of your Chapter 8 project. Doing something like this will be similar to your Chapter 8 project. Have a blessed day.